right, welcome to the Fulton Schools of Engineering More to Explore. This is the session for Human Systems Engineering. And with us today is Dr. Scotty Craig. He will be presenting about the program and I will be monitoring the Q&A box. Right now, we have very few people in the meeting, so I'm actually going to go ahead and give you the option to speak when we pause for questions. That way, if we can just have an informal conversation, that would be fine. But if you would rather type in your questions, you can use the Q&A feature. So I'm going to turn it over to Dr. Scotty Craig.
Thank you. So tonight I'm going to talk to you about human systems engineering. Thank you very much for coming. I'm actually excited to be able to talk to you today. Hopefully you will see the captioning down at the bottom of the screen. We'll see how well this works. This is an attempt for some added inclusivity in the presentation tonight. So I take no responsibility for random words that it says, nor does ASU. This is all PowerPoint's doing. So thank you very much for coming. I look forward to maybe actually chatting with you a little bit later. I do have several points in the presentation where I will pause to ask for questions. It's generally it's between every section, about every 4 or 5 slides. So let's start. One, I've already thanked you for coming, but what is this that you've come to hear about? Maybe you've had a chance to go look at our website and find out something about the program. If you haven't, that's okay. I'm going to talk to you about it tonight also. But in essence, human systems engineering is a combination of psychology, design, and engineering. So really, we are looking at how do we create things? How do we understand larger systems in which people interact with? And then how do we improve those? So that is really, once you actually start looking at kind of how is something built, how is a larger design, how does it fit into the environment that it's being used in, and then what is that human element? That's when you really start to get innovative solutions to problems. And in essence, what we are doing in human systems engineering, it is a combination of engineering and an applied science. So we are really trying to address real world problems using scientific methods. Now, the problems that we are dealing with within human systems engineering is that we often think that design is intuitive. And a lot of times when people create items, like, things are designed and built, people think that they're intuitive and that they can be used. The problem is that that is not always the case. And people mess up all the time. So, for example, take this very old example of a stove. In the stove, which knob would you actually use to control and turn on a specific eye? It's very difficult from this, most likely from the original designer. It made perfect sense. But from a person just looking at it the first time, you have no idea. Likewise, if you are driving down this road and you come to this sign, which direction should you go? Should you actually go right on the right branch, or should you actually use the left branch? From the sign, it is not clear. But again, most likely in the mind of the creator of that sign, it was very clear. In other people's mind, not so clear. And one of the things that we teach in human systems engineering is how to put information, for example, the sign, which is very obvious that it can be confusing, but put things in front of end users, so other people, and reliable ways to pull out and collect information from them to find out when things are not as intuitive as we initially thought. Okay, just a couple other fun examples, which probably a lot of you, if you remember going to hotels, have experienced this. So you come up to a door with a key. Um, you're never quite sure which way the key goes in, and you're often stuck there, putting the key in one way, then flipping it, putting it in another way. Same problem that you often have with USB drives. If you go up to a USB drive, how many people have actually get the USB drive correct every time in the first try? Usually it takes 3, minimally. So again, why is that? It's because the design is not intuitive. And finally, this wonderful example. Sometimes you can actually have perfectly functional designs, but they are not functionally useful in the overall system and for all of the users in which use those systems. So this may be a perfectly useful ATM for somebody who's driving up to it in a very large vehicle. And maybe that's what it was initially designed for, but it is not a useful ATM for a person who needs to use it, just walking up to it. So as you can see, we often think that designs are very intuitive, but sometimes either the designs don't really transfer outside of the designer's head, or human uses for those designs are different than the originally intended use. So what is it that HSE is? It is a combination of psychology and engineering to design technology that really works for people, to find all of those errors that we saw in the other examples before they actually reach people. But there's another example of human systems engineering that we have to think about, and that is that, for example, you take this wheelchair. Now, again, notice that yes, this woman she can sit here in this wheelchair, but we have to realize that yes, it's perfectly functional for somebody to sit in and for some intended purposes, but we have to realize that people are not always just sitting in these chairs. Sometimes people are actually having to live their lives within wheelchairs. So we have to think of the overall larger use functionality of an item when we create it. And that takes a combination of understanding people, understanding the basic engineering constraints, and understanding how we can actually design this technology so that it better fits all of the needs that people may be able to use it for. Now, I'm not the only faculty member within Human Systems Engineering. There's actually a group of us. There are 7 of us. And the 7 of us, oh, we have a question, yay. The 7 of us support, well, 3 to 4 different degree programs. So we have a Bachelor's of Science degree in Human Systems Engineering that we offer, which also has a concentration in user experience, which means you could just focus on the general degree for Human Systems Engineering, but if you really want to dig into and focus on that user experience piece, for example, finding issues like these and actually sorting them out, that's what that user experience piece gives you. The other thing the user experience piece gives you is things such as evaluating web designs, evaluating products, and how you can apply these human systems engineering skills to those specific areas. So that's our focused concentration within human systems engineering. And there's also the general degree where you just get all of the training. Now, along with this bachelor's degree, we also have a 4+1 program where that is a combination of a master's degree along with the bachelor's program. So what happens in the 4+1 program is you will initially start your bachelor's degree around your junior to before your junior year starts. You can apply for 4+1 program, and it allows you to blend the rest of your undergraduate program with a master's program. So you add, in essence, an extra year onto your school, and you actually finish with both a bachelor's degree and an advanced master's degree at the same time. And finally, we offer a PhD program also in human systems engineering. Now, the PhD program is really for advanced training. At the bachelor's level, you are learning basic skills and techniques for human systems engineering. You're understanding kind of how humans function. You're understanding how to implement evaluation techniques. You're understanding how to consume research. So how to read research articles and understand what they're saying and how they can be applied. At the master's level, you're showing that you can conduct this research in real world settings. But at the PhD level, which can be seen as that highest, most seminal level, you are conducting that base level research to increase our knowledge of how human systems engineering works. Now, at this point, I'm going to pause for questions because I've actually given you a lot of information on a lot of stuff. So I know we have at least one comment. And if other people have comments also.
The question was whether they can actually receive a recording of the session. So I'm finding that out now if we can send a recording of this and should have an answer by the end of the session, hopefully.
Okay, good.
Any other questions from our attendees? Not, I guess not at this point.
Okay, good. That's good. And again, so hopefully I can get that recording. If not, you will have my contact information. I think it's at the end of this presentation. You can always follow up with me if you have any other questions. So I've told you a little bit about our degrees. I've told you about some of the information that we deal with. But let me talk a little bit more specifically about what we do. So we conduct research in human systems engineering to discover what people think, what they feel, what they are doing, and what they need. The way we when we conduct this research, we are collecting and analyzing data to make design decisions and present solutions to end users. So we will conduct things such as interviews with people to actually pull out information about what they do. We have very standardized techniques that we go through to analyze that data. Normally, why we're conducting this research is for one of two reasons. Either we have a empirical research-based idea that we want to get an answer to, or we're working for a company and we want to find answers and solutions to their problems. So just an example of that, earlier today, I was giving a presentation to the US Department of Defense on one of my projects that I'm doing for them, which is a evaluation project for a system that's called Pearls. Pearls is a piece of learning technology. So it's actually a app that actually that provides micro learning to the user. So basically, that's just like learning in small bite-sized bits of less than 5 minutes each. So you have a few minutes, you pick up your phone, and you can learn a little bit about something. Later on, you have another 5 minutes free. You can pick up your phone, and it will recommend to you the next bit of information on that 5 minute thing that you learned earlier. And it kind of scaffolds you through that process. So I have been working with them to conduct user studies on that system. So we take their system, the app they've created, we put it in front of target end users, which in this case are learners and instructors who actually create content in it. And we look to find the problems that they have with the system. So, and I was presenting that to them earlier today. So that's an applied example where we're conducting research to find out how people actually use the system, what they feel about the system, what they actually do when they use the system. And I gave them very specific recommendations. Okay, so let's see if we can actually define human systems engineering a little bit better. So first off, it's human-centered in that we focus on people. We focus on people's needs, their goals, their abilities, resources, and very importantly, the environments. What environments are they working in? What are those larger systems of environments that they're in? So for example, right now, I am here in my office, and that is could be considered the environment that I'm working in. But I'm also a professor at of human systems engineering at Arizona State University within the Fulton Schools of Engineering. That is also an environment which I'm sitting in that is not a physical environment. And so we might actually have to understand when looking at environment, not just physical, but also these other types of larger environments that people have to work in also. Now, in addition to being human-centered, it also has an element of engineering and design. So we look at how people interact with or through technology. So they're either designing technologies that work effectively or efficiently with people, or designing technologies that empower people to do something they couldn't do otherwise. So if you see this picture here, the example, this person is using an iPad in a mixed reality environment. So when they look at the physical system, they would not see these levels of instructions, but by holding up the pad, it actually does give them some level of instruction. And that's some basic guidance coming from that system. Now, does that work? And that's an important question. So right now they know that, for example, they have these green things that telling them to most likely to do these things and to avoid the red areas. Does that actually work? Well, that's where we come in, because we are an applied social science, and that we look at how the brain works and how people's physical limitations could impact how people interact in an environment. We look at communication skills within the environment and more, such as example here, we have some bio, I don't know that my mind just went blank, everybody. It's a late day for me. So we do deal with some biological measures also, such as EEG and things like that we get from people for data. So really, we have to realize that within any area, within any really good applied science area, it is a multidisciplinary area, and that we're combining knowledge, expertise, and skills from many different fields. In general, nobody really does this alone. So we're training our students to conduct their research in a way that they're able to work with engineers who may be building something, work with designers. So it is possible that you might be doing all three, but likely you would be working in a multidisciplinary team to create something and provide feedback. And what we usually do when we come into the team, we are normally the research-based component, where we are helping to collect and analyze data to solve problems that have come up during development and to provide that evidence to help decision-making for the project to move forward. Okay, again, I think this is a good time for questioning. So we have gone through a lot of slides, talked to you a lot. So if there are any questions, please let me know. I'll pause for a minute or so.
No questions to the Q&A yet, but you are welcome to speak up if you'd like to. You have the ability to unmute yourself, or you can let us know in the chat. I think it's safe to continue.
Okay, it looks like there was just one comment that just came in.
Oh, there you go. It just popped up. Oh, thank you. Yeah, a thank you comment.
Oh, okay. Well, you're welcome. So let me continue on then. I want to talk to you a little bit about the methods that we're going to be using, that we use within HSE. So why I'm talking to you about the methods, I've talked to you a lot about what we do at a higher level, but now I'm going to talk to you about kind of what we use to do the skills that, to actually implement our skills within HSE. So these are some of the things that you'll be learning within human systems engineering. So different methods that we will be training you on are some qualitative methods. Qualitative methods are things such as interviews, focus groups, and observations. And these are systematic observations, where we use these to learn about people in natural settings. So this first picture here is a typical interview, where it's usually one-on-one, and you actually have a series of questions that you'll be asking people. Focus groups, it's very similar technique, where you talk to similar types of questions, but you ask people in groups, and there's a group dynamic that goes back and forth. Sometimes you can pull and elicit more information from people that way. And finally, with natural observations, with these systematic observations, you have a coding sheet. Usually you're in a real world environment, a natural setting. In this case, we have a picture of a classroom, and you're observing things that are going on in the classroom, looking for specific behaviors and making comments on them. Now, we also use experimental methods. Experimental methods this is research that is carefully controlled, that manipulates and tests very specific variables in an environment. So we might study people studying alone versus people studying in groups versus people who study maybe still in groups, but online with technology. And with this, we look at the impact that each addition has on performance. So notice these are very systematic, where it's just one small change over time. And these are normally different groups with different groups of people. Now we also use some design methods. One example of this is prototyping. So with prototyping, you actually mark up what you want your interface and design to actually look like before you build it. You can also build these with wireframes. You can make sketches. From this, you often create beta versions, and you can get feedback on it by presenting it to your users, and then you adapt it. And this is normally an iterative process that goes through multiple cycles. So again, those three techniques that I talked to you about is qualitative data, quantitative, and design-based methodologies. So are there any questions on those? Okay, so it's not really surprising that there are no, that it's not tons of questions. So, just so you know, one of my areas of research that I've actually conducted work on is on human discourse and how people communicate. And I've actually looked at question asking as one of my areas of topics that I've done research on. So what is it that can get people to ask questions? And in my research, what the best way to get people not to ask questions is? The absolute best way to get people not to ask questions.
Is it to ask them if they have any questions?
Close. It is to give them a long, detailed, oriented monologue. And then to say, do you have any questions? Because basically what happens, all that information that I just presented to you, it's basically still there in your head, kind of fighting for, for understanding. And then when I say, do you have any questions? You don't, because it's too much competing activation. So you can't get it. So basically what happens is nothing at the time. And then 10 minutes, 20 minutes, an hour later, you're like, oh, I wish I would have asked that. So later tonight, when you think of something to ask, be like, oh yeah, he said that was going to happen. So just remember that. And again, you can always reach back out to me if you do have questions that need to be answered. Now, I'm going to go on now and talk about the benefits that you get from human systems engineering. Maybe not you particularly, but these are benefits of implementing our strategies. So first, I want to talk to you about usability and productivity. So one thing you might notice with all three of these pictures is a distinct lack of the actual usability of the picture, of the item in the picture. So with usability, we are looking at ways to improve the design of products, devices, software, websites, so that they're actually more functional and more effective for their task. The next, user experience. So with user experience, we're looking to improve people's emotional reactions and perceptions of interacting with the specific system. We try to find those things that would cause annoyance and frustration, remove them so that there's more positive feelings about the usefulness of the experience, which usually leads to more empowerment of the user. Now, the next item is safety and ergonomics. So by improving design or redesigning technology with people in mind, we make that technology inherently safer, more comfortable for them, and less likely to lead to injury in the long run. And finally, this is ASU, so we also provide innovation. So with innovation, we're looking for developing better understanding of what people need, what people can actually do. So when we look at those two things, this helps to inspire new inventions and new solutions to problems. And those often make people's lives better. So in essence, we are combining engineering and how people create and build and make things with people in mind so that we can focus on the larger big picture that combines both engineering and people into a much larger system. For example, and we can better understand resources that are needed, how cities would function, people's environment in which they live in, politics, healthcare, law, communities, culture, education, social media. It keeps going. And we can actually work and understand how people work in all of these situations. Now, one thing you may have noticed as I have been talking, I've given us a couple examples of my research. So not only are we faculty that support human systems engineering and teach in this program, all of us are active researchers. And we all have PhDs, and we are actually conducting that HSE research in many different areas. So our areas of expertise have a very wide span. Everything from unmanned aerial vehicles to things like cognitive fatigue, looking at emotions and decision making, to cybersecurity, learning technologies, and even writing and writing proficiency. So Dr. Rod Roscoe, there at the bottom right, he actually conducts research on writing and how people can write, how to improve people's writing performance. So we are both educators and researchers. What that means for our students is actually something pretty amazing. Because as an incoming bachelor's student, you actually have access to all of our active labs, which means as an undergraduate, you can get involved in ongoing real research projects and get hands-on experience, not just classroom-based training. And this makes you much more desirable when you go out on the job market, which is why our program's graduates tends to get jobs when they graduate. So one thing, especially when we used to have to talk to a lot of people who knew about psychology a lot more, they were like, well, what's the difference between what you do and psychology? And we'd always jokingly say, well, the big difference between us and psychology is that our graduates get jobs. And the psychologists didn't like that, but we didn't care. We thought it was a funny joke. But really they do. And here are some examples. So they get, our graduates go into industry in places like GoDaddy, which does, which supports websites, Intel, Boeing, and Apple. So we have graduates at all of these companies. We also have graduates go into government labs. For example, the Air Force Research Lab. This is all private, public sector laboratories. They also go into consulting firms such as Exponent. So the difference between industry and these consulting firms is that industry usually has human factors or human systems engineering programs within them. Large companies do, but not all companies have that. For the companies who don't have that, they contract out to consulting firms to conduct that research. And yes, some of our graduates actually do go on to graduate school. They get master's degrees and they get PhDs. And the training at the bachelor's level really does prepare you for all 4 of those options. Why? Because you get training at from classroom-based training. So you'll get knowledge and presentation and hands-on experience within classrooms on how to do all the skills. You'll have opportunities for research with active labs with the faculty, both by volunteering in the labs and also through other programs such as the FURY program, the Fulton Undergraduate Research Initiative, where you can put in a proposal to work directly one-on-one with a faculty member and conduct research. These opportunities really do allow you to then go out and get these jobs. So now, are there any questions?
No questions yet, but I do want to add that FURY, the Fulton Undergraduate Research Initiative, the students receive a stipend of $1,500 each semester to conduct their research. And plus, they also get a stipend for the materials that they need if they need to build a prototype or they need to invest in some kind of software to do their project. And at the end of their research, they get to present to a wide audience. And as Scotty said, they are partnered with faculty mentors. Sometimes they are partnered with community members who are in industry. And so again, it widens their network and allows them to work closely with someone who's been doing that professionally. Some of our research projects, and this is not just FURY, just in general, some of the research projects that our students have done have yielded scholarly journals. So we have undergraduate students who have been published in scholarly journals. Some of them have become startups. They've been pitched to funders for potential investment. So really, the research is not just broadening the students' knowledge about a body of interest, but also really opens a lot of opportunities, even as early as their first year.
Yeah, and just to give one concrete example of that. So I've actually had several amazing FURY students that I've worked with, but one student that I actually worked with, though, Sarah Zip, one of my former students, conducted research with me on virtual humans. So we had a project, we were looking at learning with virtual humans. For those of you who may not be, aware what a virtual human is, if you have played video games, so that those NPCs that you're interacting with that are human in those games, those are virtual humans. They're basically just computerized or cartoon-like characters that you can interact with in interactive environments, computerized environments. We were specifically looking at a project that was a simulation, a training simulation for search and rescue. So we built this for what I'm trying to remember who we built it for. It was for the Army medical arm. What they wanted a simulation that trained on the new triage techniques for large-scale disaster search and rescue. So when I talk about this large-scale environment, so what we're talking about is like, imagine well, we actually had several hurricanes have come through this year. So when a hurricane comes in, and then we have to quickly, first responders have to go out and find people and determine how badly are they hurt. So that's triage in that area. So we were actually training people in that. So we created a virtual simulation where people had to go out in the simulation and find virtual patients, people who were hurt, and help them basically go through these triage methods. The reason why the military wanted this training is because what happens with people in these situations is that civilians usually go out and do this initially, but the military often comes in and there has to be a handoff between the civilians and the military. So that's why they wanted this level of training. That's why they provided the funding. But so we built the system, but What Sarah was asking though is, well, are there any differences with the way that people are interacting with these virtual patients? So when they go out to find these virtual humans that they have to help, do they treat all of them equally? Because they're just virtual characters. Why would they treat them differently? Why? It's because we know that humans tend to treat other humans differently based off of innate biases. And specifically, um, aversive racism. So what this area, this term of racism is, this is not overt, usually overt racism, like when people are actively racist and shouting profanities at people because they hate them because of something. Um, this is racism that happens because you put people under pressure and biases that they normally would never allow to come out will come out. So we look to see, did those, do we have evidence for that within this virtual world? So does it actually transfer into the virtual world? So she looked at how people interacted with virtual humans of different skin tones. She basically, we were able to record everything they did in the system, and she looked to see how long it took people to help, how many errors they made while helping people, and we also had performance afterwards, how well they actually learned the material. And what we found was that yes, there was evidence of transfer. So she actually found that darker-skinned virtual humans, there was a delay in how long it was until people helped them. So there was a significant delay in the amount of time before they received help. And there were more errors made while helping them. And these two changes, so not only did they show these biases against darker skinned virtual humans, when we looked at training, these errors also negatively impacted the training from the system also. So, and yeah, and that was published and is actually doing quite well, well received. And she did that as an undergraduate in the Fury program within systems engineering. So that being said, are there any questions? We do have like a couple of minutes, I think.
Yep. Well, we have plenty of time actually.
Yes.
So, Casey, if you have any questions on behalf of your son, you're welcome to let us know. I'm working on I'll work on getting you the presentation so that you can see it. But if you have any questions, now's a good time while we have Dr. Craig with us.
Yeah. And again, like I said earlier, usually with these presentations, it's hard to get a lot of questions. There may be questions that come up later.
I have a question, Dr.
Yes.
Craig. Do you have many students who finish their bachelor's degree in one discipline and then go into human systems engineering for their master's?
So we do have some that do that. I won't say that it's not the majority. So the majority, the majority of our students actually do come from other disciplines, but a lot of times we see students from psychology that switch into our program to get a master's.
Mm,
But we also see people coming from other areas of engineering as well.
mhm. Yes.
Um, Now, that actually did remind me of another thing another um, degree that we do offer, and it has been quite popular, which I didn't mention earlier. We have a minor also within human systems engineering. So instead of getting a bachelor's, you can get a minor. You can major in and then you can get the minor in some. You can major in something else and get the minor in HSE. That's been extremely popular. A lot of students will get a major in one of the engineering areas, and then they'll minor in HSE so they can combine the two. Okay, well, if there are any other questions, happy to answer them. If not, I guess we technically don't have to take up the entire hour.
No, we don't have to. If you have any final words, now would be a good time, and then the participants will get a follow up email after this session, so you can reach out to us that way. But also, I dropped my email address in the Q&A. I'm gonna do that again in the chat, so that if there are any questions, you can send them my way as well. And we also do have opportunities for prospective students to meet with current students one on one via Zoom. That's always a good way to get more of the student perspective. And we will schedule that around your availability. So that's request is available on our website if your son would like to speak with someone who is currently in HSC, so that they can get more insight on the student experience.
And I did just put my email in the chat also, in case you need it or in case you want it. Um, so I would like to thank everybody who came. I'm actually not sure how many people I actually showed up on the other end. I don't actually see the participants, but thank you for coming for those who did. I'm happy to answer any questions you may have. Um, and one last thing I do have to tell you about HSC, as far as kind of that getting the job afterwards. We have a very active student organization for human systems engineering, and it is partnered with our industry advisory board. So students in the human systems engineering student organization um, also get paired with industry mentors. So you get really interesting experience both as far as content, as far as learning content from your classes. You get applied research experience with faculty researchers, and you can get applied experience and feedback from industry advisors. So we really do have a really interesting program here to support um, students getting the skills they need to be successful after the program. Okay,
Mhm.
thank you.
Thank you. Thank you very much, Dr. Craig. And have a good rest of your evening.